Hello everyone. So today we're going to solve number of occurrence problem in which we have been given a sorted array of size n and a number x, and all we have to do is to find the number of occurrence of x in this array. So suppose in the very first test case there are total 7 elements. So let me write it down here. 1 1 2 2 2 3 3, and we have been asked to find the number of occurrence of 2. So as soon as we have been informed that the array is sorted, you can think of binary search, right? So that's what I did. And what you have to do is to simply apply the upper bound and lower bound technique. So let's understand what does this technique say. So the upper bound technique calculates the very last index of the element which we have been searching for. For example, let me write it again. 2 4 times and 2 3. So as soon as you apply the upper bound technique, first of all, in the binary search, you find out the mid, right? So if I give the index from 0 to 6, there will be 7 elements, right? So 0 to 6 by 2. So your mid will come out to be 3. So 0, 1, 2, 3. Here, your mid will lie. Since the element you are looking for is 2, so you have found out, right? Now, this just doesn't stop here. You have to look for in the upper bound, you have to look for the last occurrence, right? So what will you do? You will simply put your lower pointer. First, you will take the mid index in the answer variable. That this is a contender of my answer. This is one possible answer. So that's why I'm saving it. Now I will start my search from mid plus 1 to check if there is any other element which has the value 2 presented at other index. So in this case, I will point my low here and start the search from this low to high. Again, we will find out the mid. So since the mid was 3, this index is 4. So 4 plus 6 by 2, which is 5. So your mid will lie here. And then again, you check for what can I say? Since the element matches, since this 2 matches with our x, we again apply the binary search here and we update the answer as the mid index. The mid index is at 5, right? So we updated in previously it was 4. Okay. So since we have got a larger index, which means that the previous one wasn't the last occurrence of that element. The new x we just found out on the mid can be a last occurrence. Okay. So again, we'll apply the binary search by putting the low pointer here and high pointer here. And when we apply it, we found that this 3 is not equal to Rx, which means that this low index we are standing at, which was previously mid, is the last occurrence of this element x. Similarly, you can apply for the lower bound, which if you have guessed it, that's good, that it finds the very first index of the element, which means that we will be putting our high pointer here. Previously, what we are doing in upper bound, we are simply finding out the mid element. Then we were bringing the low pointer to the mid, right? Now in the low bound, we will bring our high pointer to the mid in order to find out the first occurrence. So I hope you can relate the binary search from this problem. Okay. So now let's look at the code. Even though it has been written that it is a medium level problem, it is quite easy. So as you can see, I have applied the lower bound technique here. So the start is initialized with 0. Then this is clearly a binary search. Okay, but a slight modification is here where answer is initialized with -1. And we are finding out the mid element. Okay, and as soon as we found it, we simply put the high pointer. So here I have named it as end, we are putting the high pointer at the mid -1 location. As I have said, in the lower bound, we will be putting my high pointer here. Okay. Then these are the basic binary search, the classic one. And in the upper bound, we are going to put our start index at mid +1. So if you don't remember, I have put my lower index at the mid +1 location and started the search. Okay. So yeah, that was the lower bound and upper bound function. And then I have called them. And since it has been initialized with -1, in case my element doesn't exist, for example, for the custom test case, let me write down here 4. Okay. So in that case, this upper bound and lower bound function would return me -1. And the sum of two negative numbers is always less than 0. Okay. So if this condition is not met, which means -1 plus -1, which is -2, is not greater than or equals to 0, then in that case, I will return 0. Otherwise, I will return the desired result. So let me show you it works completely fine. All right. Thanks for watching. See you in the next one.